Okay, so today we're going to start chapter 3. We're actually going to spend 3 days on 3-1. Today, Tuesday, and Wednesday. We have a quiz just on this one section on Friday. Okay, so we're going to spend 3 days covering this. We're also going to be completing the square again with the quadratics. Okay, and we're going to be factoring them to find the x-intercepts. So the first form of the quadratic function that we're going to talk about today is the standard form. So it's the ax squared plus bx plus c. The only thing we need is an a. So remember in 2.5, the basic one that we saw was this. And again, remember f of x is just a fancy way of saying y equals. So here, this is an example where my a is 1. I don't have a b term, so my b is 0, or I don't have an x, and I don't have a c, so my c would be 0. So you need to have an a, you don't need a b or a c. Now, when we go ahead and graph our quadratic function, the graph of a quadratic function is called a parabola. And we're going to see different parts of our graph here. So the point where the graph crosses the y-axis, that is called your y-intercept. We would find that by plugging in x equals 0. We also have x-intercepts. We find those by setting y equal to 0. Now, because it's going to be a quadratic equation, when we plug in y equals 0, we're either going to have to factor it, use square root method, use completing the square, or quadratic formula to get the x-intercepts. We also have the point, which is either going to be the lowest, it'll be a minimum or a maximum, and that point is going to be called the vertex. It's where our graph changes direction. When it's in standard form, we're going to have a formula that we're going to use to find the vertex, and that's going to be on the next slide. Now, the biggest difficulty I find that when we start doing this quadratic stuff, when students are given a test, and then you might see this on the SAT, when they ask you to find the x-intercepts, you might also see that same question, and they may say find the solutions, or they may say find the roots, or find the zeros. All of those instructions, find roots, find zeros, find solutions, find x-intercepts, is all doing the same technique. You're either going to factor it, quadratic formula, completing the square, or square root method, to find the x-intercepts. So all of those instructions that are here in purple would be doing the same thing, just finding the x-intercept. Let's go ahead and let's see what our formula is to find the x of vertex. And that formula is negative b over 2 times a, or the opposite of b. So we would get our b value and our a value from the standard form. So again, remember the a comes from the number in front of x squared. The b comes from the number that's in front of x. Now, remember back in our linear equations where we had an a and it couldn't be negative? In the quadratics, the a can be negative. Okay? When the a is, and if you think about it, think of our equation here. Y equals negative 2x squared. What does this negative sign tell me? And remember the shift rules? It would be a reflection. Good. So notice my a here is negative 2. But really the negative sign indicates it's a reflection. So what we're going to see later on in the notes is when I used to teach this to Algebra 1, I would tell them when your a is a positive number, your graph is going to open up. A positive person's happy. It looks like a smiley face. When your a is negative, it looks like a frown, and a negative person would be frowning. Yes?
If you find your x-intercept, your y-intercept, and your vertex, can you just graph it? Okay.
Yep. And we can also use our line of symmetry. So really, all you need to do is find the vertex by using this. Find x, plug it back in to get your y of the vertex. Then the c term is always the y-intercept. So when it's in standard form, this is going to be your y-intercept. So you really don't even need to plug in 0 for x, because you can look at it and say, oh, my y-intercept's right there. Then I could use the line of symmetry or the axis of symmetry to get the other side of the u. So graphing's not that bad. If you want to do a whole table of values and plug in numbers, you can do that also. Or you could factor it and find the x-intercepts and get points that way. All right, so let's try our first example. So again, we want to find the vertex first. I'm going to use the formula x equals negative b over 2 times a. So I'm going to identify my a. It's the number in front of x squared. There's not a number there, so it's a 1. I assume a 1 to be there. Then my b, I take the subtraction sign as a negative 4. And then my c is negative 2. Everybody good? All right, so now I'm going to plug it into the formula. And I get x equals negative 4 over 2 times 1. The negative makes the 4 become positive. I'm going to divide, and x equals 2. Now, remember the vertex is an ordered pair. And again, remember, this time I wrote the function as y equals. If it's given to you as f of x equals, remember f of x is just a fancy way of saying y equals. So, but however, it was given to us like this. So now I take this equation, y equals x squared minus 4x minus 2. I'm now going to take what I just found x to be, plug it in for x to get the y of my vertex. So y equals 2 squared, 4 times 2 minus 2, 4 minus 8 minus 2, and I get y equals negative 6. So my vertex is the ordered pair 2, negative 6. Now, in addition to this x equals 2 being the x of my vertex, this is also my axis of symmetry. And I'm going to show you what this means. So just like before, you probably learned about lines of symmetry. So if I were to draw the graph of this equation, x equals 2, which is a vertical line, through the parabola graph, it would split my graph into like a mirrored image. And I'm going to show you this on the next slide when we go to graph it. So again, same equation. My vertex again is 2, negative 6, and I have an axis of symmetry at x equals 2. So let me go ahead and get my vertex on here. I'm also going to graph my y-intercept, which was my c value. So I'm going to graph the ordered pair 0, negative 2, and put both of these points on here. And I'm going to show you how I can graph the parabola just using the vertex, the y-intercept, and the line of symmetry. So let me go ahead and graph 2, negative 6. So I'm going to come over here to the 2. Negative 6. And then I also have the y-intercept of 0, negative 2. I'm going to draw in the line of symmetry. So the x equals 2 came from here. It's an equation. So if I draw a vertical line through that point, this is my line of symmetry, or my axis of symmetry. Now, notice if I connect the vertex to the y-intercept, I've only got half of my U-shape. I need to get a third point on here to get the U-shape. So I can use the line of symmetry. So see how this point, the y-intercept, is 2 spaces away? I can go to the right side and 2 spaces away, put a point, and now I have my reflected. If you don't like to do that, you can also, this is what I call a little T-chart here. What I recommend you do is find the vertex first. We're going to put it here in the middle. Then I'm going to pick a value of x that's less than 2 to get the left side of my graph. And then I'm going to pick a number for x that's greater than 2 to get the right side. It doesn't matter what you pick for x. You can pick any number you want. So let's say I plug in the 2 numbers that I just did using the line of symmetry. Let's say I pick for my number that's less than 2, I'm going to plug in 0. And for my number that's greater than 2, let me plug in 4. Doesn't matter. You can pick whatever you want. I could have picked 3, 5, 10. Doesn't matter. So for when I plug in x equals 0, I take my equation, y equals x squared minus 4x minus 2. Plug in zeros. Solve for y, and I get y equals negative 2. Notice that was my c value. That was my y-intercept. Then if I plug in 4, y equals 4 squared minus 4 times 4 minus 2. 16 minus 16 minus 2. And again, I get negative 2. And then this was what I calculated before. So again, same order pairs that I got using the line of symmetry. Now, if you plugged in 5, granted, you're not going to get the 1 that would be symmetrical. But it doesn't matter. You're just trying to get a point on the left side of the vertex and a point on the right side. So you can connect them and make the U shape. Now, also, on the quiz, they're going to give you an equation. You're going to be asked to find the vertex. You're going to be asked to find the axis of symmetry. You're going to be asked to find the Y-intercept, the X-intercepts, if it's a maximum or a minimum. And it's also going to ask for the domain and the range. So one question is probably going to have like 6 parts to it. But we're just going to keep repeating this and we're going to practice this. And then I'm also going to show you the vertex form of the quadratic function. So let's go ahead and finish this one up. Now, when your graph is a U shape, this vertex value, this is as low as it gets, so this value is a minimum. And the minimum value it takes on is always the y of the vertex. The lowest it gets here is negative 6. That's also the number I'm going to use for my range. Does anybody remember what the domain is for all quadratic functions? Beautiful. Everybody should get this question right on the quiz. Domain for all quadratic functions is all real numbers. What changes is the range. And the range is going to change based on that vertex. And whenever it's a happy parabola, whenever that's a minimum value, it's going to be whatever this number is, negative 6 to infinity. So it's greater than or equal to negative 6. When it's the sad parabola, it'll be negative infinity to the number. It'll be a less than. So on the quiz, be able to identify the vertex, the axis of symmetry, the domain, the range, if it's a minimum, a maximum, and also be able to graph it. Also, when I ask you for the axis of symmetry, this one was x equals 2. It must be written as an equation. If you tell me the axis of symmetry is 2, you get it wrong. It has to be x equals 2 because this is the equation of a vertical line. So you need to write it as x equals because it's a line. It's not just a value. All right, let's try the next one. Just looking at this, does anybody know what kind of, is this a happy or a sad parabola? Sad. So it's going to be opening downward. Okay, anybody know what the y-intercept is? 3. Good. So right away I could see that, and now I'm going to find the vertex by using the formula negative b over 2 times a. My a value is negative 2, my b value is negative 1, and my c value is 3, which is also my y-intercept. So let's go ahead and find the vertex. Let's plug in the numbers. So opposite of b, or negative negative b, is negative negative 1, 2 times negative 2, so 1 over negative 4. So my axis of symmetry is x equals negative 1/4. This is also the x of my order pair for my vertex. I now need to find the y of the order pair. So I take that negative 1/4 and I plug it into the equation. So negative 2, negative 1/4 squared, negative 1/4 here. And now I'm going to simplify, follow order of operations. This will become 1/16. I'm going to make that negative negative a positive sign. I'm going to multiply this. I get negative 2 over 16, but I'm going to simplify it to negative 1/8. Now I'm going to go ahead and add these up. I'm going to change the 1/4 into 2/8. And I'm just going to leave it a mixed number because I'm graphing this. So I'm going to leave it as 3 1/8. Now, I know the graph that I'm going to show you on the next slide, it's just going by ones. So again, we're going to approximate this. We're going to go probably a little bit past 3. And then for the negative 1/4, maybe a little bit past the 0. Pretty good? So again, it doesn't have to be precise, just in the right general area. So my vertex here is the negative 1/4 and the 3 1/8. So let's go to the next slide. Yeah, so let's go ahead and graph this now. So again, my function was f of x, and again, f of x, fancy way of saying y equals. So this is the equation. So again, I already had my vertex. It was negative 1/4 and 3 1/8. And you guys told me that the y-intercept was 0, 3. So let's get these 2 points on the graph. And again, we could use the axis of symmetry as our line of symmetry and make it, the same number of spaces away. Or do this little t-chart and plug in. Also remember, because you're going to have to identify this, remember the axis of symmetry is an equation. So this is the axis of symmetry. This is the vertex. This is the y-intercept. So let's go ahead and graph these. So again, I'm going to approximate this. So negative 1/4, and then I'll go up to 3 1/8. So probably we could say negative 1/4 is here, and we'll say 3 1/8 right up here. My y-intercept is at 0, 3. So again, if I draw in my line of symmetry, this is going to be super microscopic here, but if I draw it in, here's my line of symmetry. So to get the point to the left side, just go 1/4 away. So this would really be negative 1/2, 3. Just connect your points and get your u. Now, again, if you'd rather do a table, that's way too small. If you want to do a table of values, again, remember our vertex was negative 1/4. Pick a number larger and smaller. Like if I plugged in 0, 0 is bigger than negative 1/4, and that gives me the y-intercept. If I plug in, say, negative 1/2, which is smaller, if I take negative 2 times negative 1/2 squared minus negative 1/2 plus 3. If you don't want to plug in a fraction, you could have plugged in negative 2 or negative 5. It doesn't really matter. So negative 2 times 1/4 plus 1/2 plus 3. This gives me negative 2/4, which is negative 1/2 plus 1/2 plus 3 gives me 3. So here are my 3 points. Now, if it asks you to find the x-intercepts, then I would factor that thing. Let's say you didn't want to put in 1/2. Let's say instead I wanted to put in negative 5. So then I would just take negative 2 times negative 5 squared minus negative 5 plus 3, negative 2 times 25. See how this is going to give me a huge number? So it would give me negative 50 plus 5 plus 3, negative 45 plus 3, so negative 42. So then I'd have to try to graph negative 5 and negative 42. So that's why I try to use my line of symmetry, or pick something that's closer. Because sometimes it's going to go really quick and get really big. Does that make sense? So again, when you're doing the table, just pick a number smaller than the x to the vertex, and then pick another number that's larger than that. And that way you'll get the left side and the right side of the U shape. Now, let's take a look at this and think about this, what we did just now on the test. If this were a question on the test yesterday, how does this graph move compared to this one? 5 up. Okay, there's no parentheses here. So this would have been a shift of 5 units up. So this is how it ties back in to the other lesson. Now, again, remember, you don't need a B or a C. Now, this one's got an A and a C. It's missing the B. So here, my A value is 1. There's no X term, so my B is 0, and my C is 5. So I can already see my Y-intercept is going to be the order pair 0, 5. If I go to find my vertex, remember it's negative B over 2 times A. So my B is 0. So I can already see that my X-intercept or my Y-intercept is going to be my vertex. So if I take that 0, that X equals 0, again, what you get when you plug in to the formula, this is your axis of symmetry. This is again the Y-intercept. So now I'll plug in the 0. And you can already see that your Y-intercept is also your vertex. So for this one, I'm going to need to do a table because I'm not going to be able to use the line of symmetry because I don't have a different Y-intercept. Does that make sense? All right, so let's go ahead and go to the next slide where the graph is. So again, the vertex was 0, 5. And the Y-intercept. So in order to get another point, I'm going to do a table here. So again, I put the vertex here in the middle. So let me pick one number that is less than 0 and one number that's greater than 0. If you want to try to keep it basic, plug in numbers right on either side, the 1 and the negative 1. But again, if you don't want to use 1 and negative 1, you could have used 2 or negative 2 or 2 and 5. Doesn't matter as long as one's less and one's greater. So again, if I plug in negative 1, again, the equation was x squared plus 5. So negative 1 squared plus 5, 1 plus 5, and I get y equals 6. When I plug in positive 1, I get exactly the same thing. 1 plus 5 and y equals 6. So now I have 3 order pairs that I can put on my graph to get my U shape. So again, let's graph the vertex. 1, 2, 3, 4, 5. Then 1, 6 and negative 1, 6. Now really, after I plugged in say this one, I could have used my line of symmetry to get the other side. Now, notice this one does not have any x-intercepts because it's way above the x-axis. It does have a y-intercept. It's only one order pair. Keep in mind that you may end up having only one x-intercept, and that's when the graph sits on the x-axis. That would be like that parent graph. All right, so again, be able to identify the vertex, the y-intercept, and in this case it's the same number. Be able to identify the axis of symmetry. Let's identify the domain. Let's say our graph was sitting over here with the vertex. Then eventually it would come over here and you have a different y-intercept.
Okay.
But if your y-intercept and your x-intercept are both 0, 0, then it's like this equation, y equals x squared. Then the x and the y-intercept would both be the same number. All right, so let's identify the red one now, not the blue. Domain. Anybody remember? Beautiful. Everybody better get this right. Domain is always all real numbers for the quadratic functions. The range, however, changes based on that vertex. And this is going to be 5. Good. And it's a bracket. Pretty good? Yes. Yes.
How do you?
All right. Again, let's identify the A. So my A is 3. My B is -4. And my C is 0. So my Y-intercept for this graph is going to be at 0. So it's going to be at 0, 0. So here, x equals -b over 2 times a, which is -4, 2 times 3. So +4 over 6, and I'm going to simplify that to 2/3. So my axis of symmetry is at 2/3. I now need to take 2/3 and plug it back in. So 3 times 2/3 squared minus 4 times 2/3. This will give me 4/9. And this will give me 8/3. I'm going to simplify before I multiply. Make this a 3. So now this becomes 4/3 minus 8/3 gives me -4/3. So my vertex is going to occur at 2/3 and -4/3. Because I'm graphing this, let me just change this to 1 1/3. This is the vertex. This is the axis of symmetry. Again, it's an equation. Don't forget it's x equals. So let's go ahead and graph this. So again, the vertex was 2/3 and 1 1/3 negative. Axis of symmetry was x equals 2/3. And our y-intercept is 0, 0. So again, if you want to use the line of symmetry, you can. Or you could do a table of values. So let's go ahead and plot these. So I have 0, 0. And again, I'm going to try to approximate this 2/3 and -1/3. So I'll put it probably about here. So this will be the 2/3, -1 1/3. Or 2/3, -4/3. All right, so now if I use my line of symmetry, that's a really crooked line. Okay, so now if I go ahead and go the same number of units away from, so like this one was 2/3 away. So if I go 2/3 away over here, I could put my point and get my U shape. So then this would be 4/3, 0. Now, again, we can also do a table of values, and I'm also going to show you how we could have factored the equation to get the x-intercepts. So let's just do a table and just confirm that these points that I plotted were good. So if I do my little t-chart here, again, remember your vertex was 2/3. So let's pick a point that's less than 2/3. So again, easy one would be 0. So if you plug that in, you get 0. This was the -1 1/3. And what I plugged in was 4/3. However, you could have plugged in 1. It doesn't really matter. Just plug in a number that's bigger. So again, our equation was 3x squared minus 4x. I'll show you the 4/3, and I can also show you the 1. So then I got to square this first. 16 over 9 times 3. 16 over 3. This simplifies. 16 over 3 minus 16 over 3. And that's how I get 4/3, 0. Now, keep in mind, I could have also plugged in 1 and still gotten another order pair. Now, what we're also going to be doing later on is just taking your equation, y equals 3x squared minus 4x. If I want to find x-intercepts, I set y equal to 0. So 0 equals 3x squared minus 4x. I'm going to factor this. GCF here is x. And now I set each factor equal to 0. So x equals 0, 3x minus 4 equals 0, 3x equals 4, divide by 3, and x equals 4/3. So notice my two x-intercepts are the same numbers that I got from my table, because see y equals 0. So that's another way that you can find x-intercepts, by setting y equal to 0. Let's try the vertex form. This is the other form of the equation you're going to see. So the other one we've been working with was called standard form. This looks like the formula I had written on the whiteboard over here behind me. So remember here, the H tells you the shift left and right. It's the number in the parentheses. The K tells you the shift up and down. Now, the A that's in front of this is the same A that's in the standard form. So this A and this A are going to be the same numbers, whether it's in vertex form or in standard form. And again, this time though, the H and the K, those numbers become my vertex. So I don't need to do the negative b over 2a. When it's in vertex form like this, you just pull these numbers out, and that's your vertex. To find the x and the y-intercepts, we plug in the zeros. So let's practice this. So again, this is just a screenshot of techniques to graph your quadratic function. So again, if it's in standard form, then we're going to do the negative b over 2a. If it's in vertex form, you just pull the vertex right out of the equation. Down here, it's just talking about the characteristics. Again, I already talked about when a is greater than 0, meaning when it's positive, you know it's going to be opening up and it's a happy parabola. Over here, when a is negative, this will be the sad parabola, and it's like the frown. And again, it's talking about the stretches and the compresses. Now, over here, when we do quadratic formula on the ones that can't be factored, if we do a problem and we get a negative number under that radical, that's going to give us an imaginary number. When that occurs, you're going to state that there are no x-intercepts.
Can you say that again, please?
Okay, so when you get an equation in vertex form, and if it asks you to find the x-intercepts, and if we can't factor it, or even if we do the square root method, if we end up with an I in our answer, there are no x-intercepts. It's imaginary. And we're going to do that on the first example. We're only looking for real solutions for the x-intercept. So let's try the first one. This is in vertex form. Can anybody tell me what my vertex is?
4, 3.
Beautiful. And again, remember the subtraction sign is part of the formula. So the number that's here, so if it's a plus sign, then what went in there was a negative. So it's just backwards, just like the shifting rules. So my vertex occurs at 4, 3. Now to find the x-intercepts, I'm going to set y equal to 0. So 0 equals x minus 4 squared plus 3. I'm going to move the 3 over, and I'm going to use the square root method. Square root both sides. Notice I get plus and minus I radical 3. So over here, soon as I see that happen, I'm going to say that there are no x-intercepts. You know, I could finish it up. My x-intercept is going to be an imaginary number. We will not be graphing imaginary numbers. So this answer is no x-intercepts. Whenever you get an I and you're solving that quadratic by plugging in y equals 0. Now, we can find the y-intercept here by plugging in x equals 0. And again, the original equation is x minus 4 squared plus 3. Plug in a 0 for x. y equals 16 plus 3. So my y-intercept is going to occur at 0, 19. This now. So notice, you have to go 2 slides. Notice where I put my x-axis, I put it really low because remember my y-intercept is the ordered pair 0, 19. And then I'm also going to graph the vertex, which is 4, 3. Let me go ahead and graph these. Let me count 19 up. Okay, so 0, 19 is way up here. Then I'm also going to graph the ordered pair 4, 3. And now I could use my line of symmetry to get the right side. So right now, I've got this. And then again, I can draw in my line of symmetry here. And notice that this one is 4 spaces away. 1, 2, 3, 4. So I can go 4 spaces over here. 1, 2, 3, 4. And get the right side of my parabola. Notice it does not touch the x-axis. This is why there were no x-intercepts. It's up above the x-axis. So your axis of symmetry, again, is the x of the vertex. Your y-intercept is this 0, 19. We found that by setting x equals 0. This was the vertex. The domain of this is what? Beautiful. And then the range? 3, infinity. Good. And then there are no x-intercepts. It does not cross the x-axis. Okay, so here it's numbers 13 through 25 odd.